Hey everyone, and welcome back to this class, Advanced Convolutional Neural Networks. In this section of the course, we are going to look at a novel CNN architecture. This is a very interesting architecture in deep learning because it diverges from typical LeNet derivatives where, as you've seen, they basically look like the LeNet, but with different numbers of convolutions and dense layers. So what is our action plan for this section of the course? First, we're going to discuss the ResNet architecture. We're going to explain where it comes from, why it makes sense, and what problem it solves. Once we understand that, we can look at some code. Like the VGG, ResNet is also built into Keras, so there's nothing you really need to do if you just want to use it. However, I thought this was a great opportunity to exercise our TensorFlow skills, and so as an optional exercise, we're going to build ResNet in TensorFlow. We'll copy the weights over from Keras, since Keras makes it really easy to download pre-trained weights, and we'll prove that our TensorFlow implementation is equivalent by showing that it outputs the same thing as the Keras model. This one is going to be tough, so you'll want to make sure you have pretty solid TensorFlow skills. Just remember that it's optional, so you don't have to do it if you don't want to. It won't affect your understanding of the rest of this course. It is, however, a very good exercise. Finally, we're going to use ResNet on the fruits dataset, which you saw in the last section, and also a new dataset which looks at images of blood cells. This is really cool because most of us, myself included, probably have no idea what we're looking at when we look at blood cells. So it's kind of interesting that we can already build a program that's smarter than us in some sense. It also touches on what I believe is one of the most important applications of machine learning, and that is machine learning for medicine and healthcare. Machine learning has a lot of potential here. We've already created models that can look at various images like MRIs and CT scans to diagnose disease on par with experts. And by definition, experts are rare, and so not every hospital is going to have them. The great thing about machine learning models is that they can replicate very easily. So if you have an expert machine learning model, it's really easy to deploy it to every hospital in the country, versus whereas a human expert is only going to have so many hours in a day when they're available to work.